Okay, I'll start off first with some definitions, because not everybody may be familiar with what is going on. And the first thing is coral bleaching. I'm sure you've heard the term, and you've also probably heard it in terms of global climate change. We hear that the sea surface temperatures are heating up, and that we should be ready and anticipate greater episodes of coral bleaching. So what is coral bleaching and why is it bad? I mean, that's the first thing we need to know so you understand how important it is that we protect our reefs now, not later. We want to be in a proactive mode rather than a reactive mode. So first off, definition. Bleaching is the loss of a symbiotic algae that lives within the coral tissue. Now this algae produces food from the sun, photosynthesis, and it shares that food with the coral animal. If you look at this background picture, you see all these little white sort of flowery things. Each of those white flowery things is a coral polyp. Now you notice they're white because the coral animal itself, most of the corals are very translucent, and that's just the white coral skeleton showing through. Now the reason they look brownish or reddish or tannish out on the reef is this algae that lives inside the tissue. And when these corals get uncomfortable, then this algae leaves. Now the problem with this is that this algae that lives inside this coral tissue here provides about 90% of the coral animal. Each of these animals are coral polyps, 90% of their energy budget. About 10% they still have stinging cells in here and they'll feed themselves. But 90% of that is from the algae sharing food with them. So when they bleach, when sea surface temperatures gets too warm or there are other local stressors that disrupt this symbiotic relationship, so this partnership, then these coral animals are pretty darn hungry. So it would be analogous to you and I not starving, not getting no food, because they do feed. They have tentacles they'll eat. But it would be about like us living on celery. All the celery you want, all day, every day. You're going to get hungry through time. And you're going to start to use up your lipid reserves. Some of us are going to last a little longer. Some of us, especially the younger ones, they're not going to last very long at all because there's not much reserves. The same is true of the coral animals. When they bleach and the algae leaves and hunger sets in, they're going to survive for a while. Now, if that hot sea surface temperature cools down rapidly, they can regain that color. The algae will go back in, reestablish that partnership, and it's fine. The problem with global climate change is they're anticipating that these bleaching events will be increasing in frequency and duration. And the longer they bleach, the hungrier they get. And indeed, it can lead to reduced growth, reproduction, and long enough death. And just so you're aware of the threats to reefs worldwide from coral bleaching, in 1998 there was a worldwide mass bleaching event, and we lost 16% of the world's reefs in one bleaching event, and that was associated with an El Nino event where the the sea surface temperatures rose up all around the world. So already, back in '98, we got hit pretty bad. Now here in Hawaii, we didn't get hit back then. We missed it. So this is a good thing. But are we here in Hawaii immune? Well, actually we're not. We didn't get hit in '98, but we've had actually three now mass bleaching events in Hawaii. The first one occurred in 1996 in the main Hawaiian Islands, predominantly Kailua and Kaneohe Bay on the island of Oahu. And these are enclosed area with reduced water circulation. So these embayments are really ones we want to keep an eye on, like Kaneohe Bay. So these are areas that that's why we target so much focus on these, because we need to protect them. A second event occurred up in the northwestern Hawaiian Islands, up in the upper end here in 2002. And then a minor one again occurred in 2004. So already between '96 and then 2002, 2004, we're already starting to see these increases in bleaching. So I was fortunate enough to be up on a NOAA ship in 2002. That was my first trip up to the northwestern Hawaiian Islands, and I saw this event firsthand. I'd learned about coral bleaching. I'm a coral biologist, but I had never seen it. And I tell you, when I dropped down on that first reef, and looked down, it literally looked like someone had dumped snow on the reef. I couldn't believe my eyes. I mean, I'd heard about them. I'd seen pictures, but I wasn't prepared for what I saw. Whole reefs, white. This is just to show you what I saw at Midway Atoll, which is one of the reefs, one of the areas that were hit most hard by these bleaching events. What we see is some rice coral here. In the back reefs of Midway, there's these big mounds of these. And you see there's the purple rice coral, and this is supposed to be the brown rice coral. But as you can see, all that algae's gone, so now it's white. Now, one thing I want you to learn from tonight's lecture is that not all corals bleach white. As you see, this one is bleached too, but in its skin, in its tissues, it has some purple pigmentation that's natural, has nothing to do with the algae. So when this bleaches, it's usually much browner. When it bleached, the pigment stayed in there, so it's purple. So that's one thing we want to train you on is, what does bleaching look like? For most corals like this, for some corals like this. So this is what I saw in 2002 in September. I went back there in 2003, and this is what I found. And what you see is a lot of mortality. These mounds now have all these algal areas that used to be live coral. You see that the purple rice coral survived much better than the brown rice coral, which is just little bits here. I've been up there again in 04, 05, 06, and what we're now starting to see is a shift in the community structure as this purple rice coral starts to take over from the brown rice. So we're already starting to see some degradation and some shifts in our coral reefs from